Hello everybody, I'm Storm here, and welcome back to Kerbal Space program. In the last episode, I redesigned the hydroponics module for the moon base, and then launched it, flew it over to the moon, and tried to land it, and it did not work very well. And then I had to do another small adjustment. Brought it over again, was able to actually land it, but upon landing, the tracks that I was using did not work very well at all. They worked fine to move it backwards and forwards. Problem is it wouldn't turn, and when I was trying to turn it, the entire vehicle slowly tipped over. And when it did, something exploded. And then that explosion caused crazy physics things to happen, and it went flying, and then it has deposited debris all over this crater. So, you know, oh well. But as you can see, I went ahead and made another slight adjustment to the design. I added wheels instead of tracks. The whole point of the tracks was to allow the vehicle to rotate on its own axis. They would assist with, you know, lining things up. But the wheels work perfectly well. Landed it, no problems. And the wheels work perfectly. Got it all hooked up. And so now it's ready to go. Finally. So, there we are. This is going to be a method that I'm going to try to use for the rest of the modules that I'm going to put on here. So I'm going to have to come up with like some sort of like connector node that has these things on it, and maybe something like that. We'll have to see how it all goes. But all future modules are going to have to be mobile, so they're all going to have wheels of some description on them. So it'll be interesting. But now that I actually have this module attached, I can actually get my Kerbals out of, you know, there's an actual airlock there. I can get the Kerbals out, and we can take care of the next stage of what we're doing here. I just need to hook this reactor to the actual base so that it can provide power. So that's what we're going to do. All right, to that end, we're going to go on an EVA. What I might end up doing here at some point is EVAing a Kerbal and just going through and trying to clean up some of this mess. But, you know, I'll just leave the mess. It's a monument to, you know, failure always being an option here in Kerbal Space Program. All right, so I should have a pilot and a couple engineers. So I guess Burport. Burpunt Kerbal. Kerman. And transfer over there, and then you can EVA. There we are. I'm gonna turn that off. All right, let go. Okay, that doesn't quite reach, but the I do actually like that. It's just really annoying. In some situations. Let me see here. Can't seem to find the setting. Let me just do one more check. I found the setting. It's actually Flight Engineer. If I turn on this, it shows it. If I turn that off, it doesn't. Perfect. All right. Hopefully, I actually brought everything I'm going to need. I'm pretty sure I did. There we go. Oh, I put the flag down. Oh, crud. It's fine. It's fine. Take down the flag. We don't need the flag. All right. Okay, what I need is a joint socket. Okay. And let's see. That's over there. I think putting the joint socket here. Okay. Here we are. Oh, that didn't actually attach. I gotta, let's see. Ah, this button. This part cannot be attached without a tool. Okay. If I put the tool in the Kerbal inventory. Okay. I need to figure this out. Hold on. Okay, actually, that actually was quite simple. Equip. There we go. So now I should be able to attach that. There we go. There we go. Okay. So now that that's attached, there should be a way for me to get a connector going. Was it because I was still interacting? Let's see if I close that. Alright, so it looks like there actually isn't a part that I'm going to need. These are the connectors. I do need these connectors. It's a joint socket. But this base should be able to operate even without the reactor. So, why are you having so much trouble moving? Probably because you're carrying around something in your inventory. This is easier. go ahead and put the tool back as well. Okay. So what I'm probably gonna have to do is do a small service component. I'm gonna have to send over here, which is fine. Let's go ahead and open up these guys. Let's turn the lights on. All right. And then let's start agroponics. Start agroponics. It needs fertilizer. Start the life support. There we go. Now, do I know how long the Kerbals are going to last down here? It says 30 days. Alright. Let's head back to the Space Center. So I'm going to need to put together another little module, but at least I've hopefully learned a bit from that whole adventure. All right, so container module. All right. What do we have? We have what, 9 inventory slots? No, I just gotta figure out where that like extendable connector component came from. Radial attachment decoupler, huh? There it is. The extensible tube. Alright, that's actually not what I'm looking for there. Okay, I'm more looking for something like hitchhiker storage? No. Anti-habitation module? Itinerant service compartment. You've got a bunch of electric charge. No, I'm actually looking for something that's more structural, I think. Let's see. Pressurized crew tube. Multi-point station connector. That could be what I want to do. All right. Let's see. I would need caps. I think these are the caps that we use. Right. Battery pack there. Control unit there. And a docking port on the top. All right, now I would need 3 of these. One. So the existing connector would attach here. And then these other connectors would attach there. And then we would need some sort of means of moving this thing around on the surface. This thing is going to be so unstable. I think I can actually fix that. Alright. So, for structural purposes, we could put a... that might be a bit too large. Not large enough. No. There's this. That could work. Yeah, I think that's probably what we're looking for. And then we would need wheels of some description. we do radial. Yeah. No, I want to go here, and then that's when we turn on the radial, right? All right. I think this will work. What I want to do is do move, though. Move them in a little bit. It looks a little odd, but it should work. Alright, so for the ground, I guess we'll just use these same wheels that I used before. It's interesting that that's the way they're mirroring. So you want to give a little bit more ground clearance than that. About there. Okay. And then let's put those one upside down. I'll have to test drive it. Looks pretty close. No, these need to be a little bit lower. Yeah, that's pretty close. It's gonna be so unstable. It's gonna be so unstable. All right. This is going to be a ground utility module. Okay. Because then that should allow me to attach a few things to it. Like, for example, we could do the Kerbal attachment system, and I could attach a couple of these. Right? And then those guys. And actually go ahead and attach there. And then for life support, what I actually want to do is we're gonna need some like fertilizer bags. At least on this one. Actually, see if I attach the fertilizer bags here, right there, and then we maybe just do a couple of mulch bags, because mulch should generate automatically. Yeah, we're actually going to need you guys to have some mulch in them. Yeah, there we go. That's like 5. Yeah, I'm going to have to actually balance that out. Because once they actually have mulch in them and fertilizer in them, then they actually have mass. No. That's not what I want right there. Does it just copy that? Yeah, there you go. Okay, so those have fertilizer in them. And we have mulch. Okay, so that'll help kind of kickstart the aquaponics. And then here, what we're gonna need, not the winch, we need the resource transfer station. Come on. I have to remember how to do this. There we go, just click drag. Alright, let's bring a few of those. Let's bring a few more of these. Let's make sure that we have a tool just in case our Kerbals need it. Cable hook. Oh, those are the containers, right? All right. Snacks. Fixed telescopic joint. A winch. No, shouldn't need the winch. Pylon. Okay, so that can't go in there. Alright, so over here, we'll take some of these. And then we'll bring up... Oh, no. I can bring one pylon spool. And some more sockets. 158, 166 kilograms. How much does this mass? 446 kilograms. Ooh. Don't think we're gonna get anywhere close to that. No. Well then, let's see. Maybe we don't need that many resource transfer units. There we go. 238 kilograms on both, so that should be nice and balanced. Alright, let's save it. And then let's try to drive it. What I'm probably going to do is throw... Throw some solar panels on the top of it, just like that, and let's see what it does. Let's launch it. This is going to be funny. First off is going to be... Do the wheels even go in the right direction? There does seem to be some fighting going on. All right. All right, so let's go ahead and let's say we turn off the motor on those. Oh no. Let's see. Motor direction normal. Let's see. Let's take motor direction invert reverse. Because those are paired. Oh. Crab steering. All right. Oh, and there it goes. Okay. Well, let's recover it. We're gonna need to control each wheel individually. All right, so how are we going to do that? Actually, it should be fairly simple. We just put each wheel on by itself. All right, and I need to make sure that it lines up right. Okay, so you're going to be there. Okay. So now it should treat each wheel as an independent unit. I should be able to control each wheel to go in the direction that it needs to go in, where it needs to go in that direction. All right. So let's see here. Let's turn off these two wheels. All right. So then let's go ahead and reverse your motor direction. Okay. So actually, let's go ahead and reverse yours. Norm. Okay, there we go. Okay. All right, that's interesting. Okay, so steering off on those wheels. No motor, no steering. Okay. And then this guy's going to have inverted steering direction. There we go. It's actually a lot more stable than I thought it would be. Yeah. Probably because it's got all this mass down here. It's got these, basically, it's like 500 kilograms of ballast on the bottom. It's keeping the, keeping that center of gravity low. Means now things will be different on the moon. Okay, so this motor is direction reversed, steering normal. Steering reversed, direction normal. Okay. Direction reversed, steering normal. Steering reversed, direction normal. All right. Let's see if I can remember that right. All right. So, direction reversed, steering normal, steering reversed, direction normal, and then we disable steering and the motor on these other two wheels. Save that. All right, now do I actually want to put... It all depends on where I want to connect this. Yeah, I'm going to go ahead and put that on all four directions. All right, so now I need the thing that will deliver this to the surface. Docking port. Let's see, fuel tank. I could go with a procedural tank. I want the diameter to be at least 3.75. Okay. Let's see. This is liquid fuel and oxidizer. Let's see if we go with very small engines. We need to set this to the moon, right? Let's see. Mark 2, 0.625 millimeter. What does that do? Thrust to weight ratio on the moon is 2.86 with a delta V of 1700 meters per second. That is a lot better than I was anticipating. This is basically the same engine with a different look. All right. .56 was 1697. So those are actually not quite as good, though they look a little bit better. 280 vacuum, 295 vacuum. This is what, 320 vacuum? Magnetoplasma dynamic engines. No. This is what, 935, but it uses LH2. Orbital maneuvering, that would need 315. Yeah, not as good. I think these are our engines right there. But we're not quite done. We would need some sort of control module, obviously. We would need let's see, we would need reaction wheels. That's what I'm looking for. Reaction wheels and some power of some description. With some solar panels. I would guess. Yeah, that would do. Okay, so I think that's what we need. That'll do. How much does this thing mass? 18.5 tons. That's hardly anything. It's hardly anything at all. All right, 2.5 meter stack decoupler. We're gonna need that remote guidance unit. It's gonna need its own power supply. Power. We're gonna need that structural adapter to get out to 3.75. What do I want to do 3.75? I think I'll try 3.75. Alright, so then we're going to need a payload fairing at 3.75. Oh yeah, this is the type that actually needs... it needs that. It's supposedly recolorable. I kind of like that. Alright, we'll go with it. Sure, why not? Alright, and then... fuel tanks. And we should just be able to build a fairly standard rocket on top of this. Now for solar panels. We'll just stick to these. All right, and then for engines. That gives me what? 3,340 meters per second, a delta V. On that guy alone. Like this could almost get me to orbit. Well, then what I could do is go with the smaller upper stage, because we probably don't need all of that. Smaller upper stage with that good engine. That gets me what, 2,200 meters per second? Yeah, that's perfect. Well, we need to put the solar panels back on there. There we are. Oh, and you're probably going to want... a reaction wheel. .75 and first stage booster with, let's see, 800 ASL, These things use, what? LH2. This has an alternator on it. This one does not. 1,300 kilonewtons of thrust. 1,800 kilonewtons of thrust. Uh, 3-degree gimbal. Alright, so if we were to switch the tank here to just liquid hydrogen, what do we see? We see 1,200 meters per second of delta V on that atomic aerospike. Thrust to weight 1.24. Yeah, that doesn't quite get the job done. It does not quite get the job done. Liberator atomic rocket motor. No. If you put this on there, we get 2,300 meters per second of delta V. We get 1.94 a thrust to weight ratio. We could probably use just some small kick boosters just to get us off the pad, but this should be more than sufficient to get the job done. Let's get this oriented where it needs to be. Good. Light. Separate. Light. Separate. We should probably pop the fairing before blowing that stack decoupler. That would be a good idea, I think. There we go. Alright. Save it. Let's see how she flies. And we'll continue to use the autopilot because it's just so much more efficient than I am with my, fumbling controls. So, I could try a manual launch. It's been a while. Yeah, sure. Let's do it. Why did that not stage correctly? There we go. Okay. It would help if I actually give it some throttle. Fortunately, I didn't break the engine. Alright, looks like it's still going to limit me in terms of dynamic pressure. Not quite angled over as far as I'd like at this point in the flight. So we're going to come up a little bit high of an arc. We are going to make it to space. Alright, I'm not actually going to use this engine, because we're fine as far as apoapsis right now. Once we clear 70 kilometers, we'll pop the fairings. I did not put solar panels on any kind of action group. That was a slight oversight, but that's all right. There we go. Let's at least get a couple of solar panels extended. Let's get my maneuver nodes set up. There we are. Lock onto the maneuver. 1,000 meters per second of delta V. That's going to use up a lot just for circularization. But that's okay. I hope. Alright, so that's going to be, what, a 45-second burn in 40 seconds, which means we talking 23 seconds, give or take? T-minus? Right. There we are. Okay. Good. Alright, next I'm going to use this. Not editor. Planner, please. There we are. Set US target. We're going to do our transfer 917.9 meters per second. That'll do. Go ahead and execute that. I'll let the computers do this one. I'm kind of a little bit on the edge as far as fuel. All right, let's go ahead. Well, I'm gonna wait till we're actually in position before I can start deploying the rest of the solar panels. All right, let's get this one extended. Let's get this one extended. And let's get these guys extended. All right, I'm hoping I'm going to have enough Delta V to circularize once I arrive. That is going to be a question mark. All right, let's just warp over there. Okay, there we are. Circularize at the periapsis. Create node. We do have enough Delta V. Very good. I don't know if we're going to have enough Delta V left to deorbit. That's going to be, well, deorbit the upper stage. This thing has plenty of Delta V for the deorbit and landing. All right. We're circularized, so let's go ahead and let's separate. All right. See, I did not put any relay antennas on this, so I do want to deorbit it. Swing us around retrograde, and then let's... Oh, that is enough. Good. Okay. There that goes. Alright, make sure that we're controlling from the right spot. And then we're going to do the landing guidance again. Set as target. Set my landing coordinates. And we should have enough relays here now. Yep, we're relaying off. Okay. This time the land is going to be 18 minutes, give or take. So, I'm going to let this thing do its thing, and then when we're on the ground, hopefully, nice and safe, then I will be back. Okay, we are... what, a minute and a half away from landing? Give or take? So let's see how it does. Use our landing indicator. It needs to be sufficiently far away from the existing structures. Gonna be awfully close. No, we're actually gonna be fine. We'll be fine. Alright, we have 700 meters per second of delta V left in the tank. Now, my only concern is that this is adding a bunch of additional mass high on the vehicle. And I'm hoping that we don't land on too aggressive a slope that might cause the whole thing to tip over. So I need to be ready to decouple that node, like, right away. This looks relatively... good. Alright. Get the brakes on, get the brakes on. Alright. So let's decouple the node. Make sure we select the right thing. probably could make it to orbit with 700 meters per second without the port. Yeah, 1800. But this thing doesn't actually have any communications equipment or anything that would be useful. Alright, we're just gonna let this guy do its thing over here. Let's switch to that over there. And let's see if I set these wheels up right. All right, so the wheels are turning correctly, but again, we're having that issue where it does not want to drive forward. The wheels don't want to seem to work. Oh, the brakes are on. That would be probably a reason why the wheels don't want to turn. Oh, this thing is going slow. In fact, we're rolling backwards. That's not good. Okay. We're gonna need to turn the motors on the other wheels. Okay. Let's see. Reverse. But we're not gonna steer. Okay, that's wrong then. You're reversed and you're normal. Okay. Traction control. Okay, I think something may be wrong. All right. Get the brakes on, please. Get the brakes on. Brakes on. Brakes. Turn off these motors. Okay, let's turn off that motor. What direction do I go when this... let's see. Yep. That's what's going on. Your motor direction needs to be reversed. Okay. Actually, let's turn the motor off here. Turn the motor on there. Yep, and then you need to be... I think I am going to need the extra power of the other wheels. right, so. Oh. Probably because I didn't turn that motor on. Still probably going to need to power the other wheels. Okay, so brakes on. Same deal. Let's turn the motor off there. Let's turn the motor off there. Let's turn the motor on here, and let's see what direction it goes when I press that button. Wrong way. Okay. Reversed. Okay. Disable that motor. Enable that motor. Okay, that's going the right way. All right. Enable all the motors. Disable. Whoa, 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 whoa. One of the things I didn't want to do probably here is turn the torque off. There we go. We have enough power. It's just a little tipsy. That's all. All right. Let's see. I can get this guy lined up and get it all connected. It's a little tall. But it should still work. Yep. Now. There we are. I'm going to leave that like that. And then what we're going to do is we're going to extend all these arms for future use. All right. Okay. Okay. Now what I need to do, what I want to do is fertilizer needs to go in here and in here. Mulch needs to go in there and in there. Okay, so you now have mulch and fertilizer. And that means you should actually be increasing your supplies. Yep, the amount of days they have available is going up. So, yep, this is pretty close to self-sufficient now. All right, now what I just need to do is EVA again. Equip that, and then let's grab one of those. I think it's actually, oh wow, the weight, the mass of that piece of equipment is such that the RCS doesn't actually work. Okay. Now, if this works the way I think it should, what I should be able to do here is go ahead attach this here. All right. Grab the connector. There we go. And let's see, how far will it let me take this connector? Attach the connector. There we are. So that should now allow this reactor to provide power to the base. Okay, now is this reactor even on? Now, I wonder if I did that backwards. Is that thing even on? Because I would expect those radiators to be warm. I'm not running. The reactor is on. There we go. That's what does it. Okay. So it basically now treats them as if they are docked. I think. Let's see. If the batteries are completely recharged, then... Yep, there we are. Okay, so now we are drawing power from that reactor for the rest of this base. That's good. Now, what I actually might want to do is something a little bit different here. Let me try something here. All right, inventory, inventory. I want this pylon. I want one of these, and I will need one of those. I think. Yes. Now, attach the connector. Okay, that's interesting. Here's what I'd like to try to do. I want to put a pylon down. Let's see. Right around here, because I want a place where we can just start kind of linking these things together. So I want a bit of a node. Pylon. This should be attachable, like, straight to the ground. It actually has an attachment node on it. Okay. Okay. There's a ground node. Good. Okay, so this popped out. Oh, right, I'm still carrying one of these things. Let me... Like, I want to attach this here. I think. Okay. So that's attached there. No, I'm not so heavy that the RCS won't work. Okay, what do I do about this cable here? Ah, there we are. Pick up the connector. Okay. All right. Attach the connector. Link mode docked. Okay. And then I grab that connector there. Well, actually, probably would have been better to put this on that. But this will work. This will work. But in the future, what I want to do is I want to put that on the module and then this on the node. Link mode docked. Okay. Electric charge is good. Everything's good. So now what I want to do is decouple that node. And then, control from here. Okay, I don't know what in the world it's doing. Control from here. Let's see. What's it gonna do? It's gonna crash pretty far away, so that's fine. That's all I really needed, was for that thing to just crash somewhere. All right, so I think in order to get this thing up and running, what we're going to need next is a miner. So basically a drill. So drop here. It's going to drop pretty close. So drop a drill in. And we're going to need like some storage tanks. I don't know if I want to bring that in a single vehicle or multiple vehicles that all have kind of storage tanks on them. But those are the, or if I want to put some storage tanks on the drill, that might actually be a good idea. It's just put some small basic storage tanks on the drill module, just so that we have something to get started, and then I can see how everything's going to work. We're going to need also an ISRU converter to hook up so that we can turn materials into useful items, especially for this base, just so the space can be self-sufficient. So, I think that will do. Coming along. It's coming along. So we'll go ahead and end this episode here. So hope you guys enjoyed it. Thanks for watching. Go ahead, like, subscribe, and comment, and I will see you next time.